This is a pre-session video for session 3 in mus119, where we're going to look at the creation of a sequencer and sampler in Pure Data. In Mole, you will see this video. You will see the sequencer drum sound file.zip, and if you click on that, you will get a download, and you'll find that in your downloads folder. If I open the containing folder, there's a downloads. This is a zip file, so you can open this. It contains a folder. I'm now going to put this in my mus119 folder. So I get a new window, I find my folder mus119. Yours will be on your U drive. So there's my mus119 folder, and I'm going to just drag my sequencer folder from my downloads to my mus119 folder. That extracts it at the same time. In this folder here, I have a file called hip hop drums. This file looks like this, sounds like this. And I hope we've got sound in this video. You will note from that these sounds are regularly spaced at 0.5 of second intervals until the last sound, which is 2.5 seconds in. In PD, make a new file, and we're going to think about making a sampler and a sequencer. So we need two aspects of this sequencer. The first aspect is to make something that will play the sound once we've loaded the sound into memory from different starting points. We also then need to think about how the sequencer might work and how you'll be able to create patterns. So we're going to start with the bare bones and then build it up on Friday in our class sessions. To begin with, let's work on the audio side. So put object, and it's definitely, we need a digital to analog converter, and then to open a sound file we need an object box called sound filer. Now I've started working and I've not saved, so I will save, and I need to put this in my sequencer folder, and I need to call it my sequencer. Notice it's just appeared here. It's very important that your PD file and your audio file are in the same folder for this experiment. The sound filer takes a message to load a sound file, put message, and we're going to read the sound file, but we don't know, we're going to read it into some memory, but we don't know how big that memory is going to be. So we're going to make it the size of the sound file. So we're going to resize the memory. So minus resize, then the name of my sound file, hip hop drums, and it's a .wav. And then I'm going to load this into memory, into what's called in PD a table, and I have to give that table a name. So I'm going to call it my drums. And I send this to the sound filer. But I now need to create the memory to put this sound file into it, so I put an object box, and I'm going to make a table, and I'm going to call it my drums. There are two ways in PD of assigning memory to load sounds into memory. One is a table and one is an array, and broadly speaking they are the same thing. When I click Control or Command on a Macintosh, you notice my mouse changes. And it kind of gets me out of edit mode just on the fly. I can click my table and I can see a blank section of memory. And when I click this message box, it loads in my sound file. All going well so far. To play my sound file, I need an object box called tab play tilde. So this is going to play a table, and I need to assign the table that it's going to play. So tab play tilde space my drums. It has two outputs. The output on the right here just tells me when a table has finished playing and is useful for looping. But we're just going to use this output here, as my sound file is mono, and I'm going to send that to both the left and the right channels of the DAC. Now tab play takes a starting position and a number of samples to play at the sample rate. And in the class on Thursday we're going to talk about samples and sample rates. But for now we put a message, and I'm going to start at 0 samples, and I'm going to play for half a second. Well, you've probably already heard me talking about sample rates, and the normal sample rate that we use in class is a sample rate of 44,100 samples per second. If I'm going to play half a second, I want half of that, so it's 22,050 samples. So it just says start at 0 samples and go to 22,050 samples at 44,000 samples a second. So I'm going to play half a second. I'm going to play this sound here. Now make sure that your DSP is on. Just click on this message box and we should have some sound, and I hope I'm recording sound because I don't want to remake this video for a third time. If I duplicate that and I want to play another sound, and let's say I select the sound that's 1 second in here, this one. So 1 second, 44,100, because there's 44,100 samples per second. So I've got 2 different sounds. Now I need to make a method to enable me to select at certain time points one or other of these sounds. In an earlier class we looked at how to make a metronome using a delay object. Fortunately, in Pure Data there is an object that does this for us, metro. And metro takes a starting time value, but we will obviously change that. So metro space 1000, so this number here is not samples, it's milliseconds. So this will give us crotchet equals 60 beats per minute. Metro is turned on and off using a toggle box. Put toggle, 1 to turn the metro on, 0 to turn the metro off. Now we need a method to get a counter going. Put an object box. I did that last time. Put object, and I'm definitely going to want to increment my counter by +1 every now and again. So what I want to happen is my metro delivers a bang, gives me a number 0, which then goes into a +1 box, comes out of that back into my number, which is a storage unit, and waits for the next bang to bang that number out. There's a very useful box here called, it's an object box, I for integer. You will also see a similar box called F for float. In this instance we'll mainly use integer for our counter because I only want whole numbers. I put the bang into my integer box. The output of my integer box goes into the +1. The output of the +1 goes into the storage inlet of the integer box. And now if I just add a number box to here, I should see 1, 2, 3, and this is carrying on counting all the way up until I stop the metronome. This is not what I want because I just want a number between 0 and 7 so that I can create 8-note patterns. So I want some way of restricting this to the numbers 0 to 7. Remember back in your GCSE maths, or earlier even than that, when you asked how many 4s are in 8 and the answer was 2, and then you were asked how many 5s are in 8, the answer was 1, remainder 3. You were asked how many 2s were in 8, it was 4. You were asked how many 3s were in 8, it was 3, 6, 2, remainder 2. Well, all we need to do is do some division by 8 and just take the remainder. So we'll get increasingly multiples of 8, but we'll just see the remainder. And to do that, we put an object box and we put the % sign in there, space, the number we want, which is 8. So 80 divided by 8 would be 0. 85 divided by 8 would be something, remainder 5, because there'd be 5 left over until we got to 88. Let's just check that out. Put a number box there. 7, 0, 1, 2. Lo and behold, counter from 0 to 7, giving us 8 possibilities. So we just need to select from these possibilities. Select in an object box. 0, 1, 2, 3, 4, 5, 6, 7. Join that up to here. The select object looks for the number and sends a bang out of its respective inlet. So if I put my select 0 to my kick and my select 3 to my other sound, just bring these down here, start this up, 1, 2. Obviously there's a long way to go to develop this, and one of the things we're going to also have to look at is tempo. We want tempo in BPM as opposed to a number in milliseconds. We did this in a previous class, although I don't think every class got to figure this out, but do ask around to try and get the formula. It has something to do with 60,000, and we're going to use the EXPR object. So if you don't know how that works, put that in an object box, right click and get the help for that. See if you can figure that out. If you can't figure out making BPM, put a number box and just lock the patch down, Control E, type in a faster number, 200. And then we could make some patterns here. So we need to figure out how to play multiple sounds at once, which we can't do right now. We need to figure out the tempo, and maybe think about other aspects of what makes a sequencer. So for now, if you copy this out, we can flesh it out in the classes on Friday. Good luck.